How do you solve for and graph the axis of symmetry and the vertex of a quadratic function? F of x is equal to x squared plus 2x minus 1. In this lesson, you will learn how to find the axis of symmetry and vertex of a quadratic function by solving part of the quadratic formula. The quadratic formula for a standard form of a quadratic equation is f of x is equal to ax squared plus bx plus c. The quadratic formula is equal to x equals negative b plus or minus square root of b squared minus 4ac all over 2a. The a is the coefficient in front of the x squared term. The b is the coefficient in front of the x term. And the c is the constant number. An axis of symmetry is a vertical line in a plane figure that divides it into two symmetrical parts in such a way that the figure on one side of the axis is a mirror image of the other side. I have a coordinate plane. The axis of symmetry will cut the triangle in half in such a way that on one side of the vertical line is equal to the other side of the vertical line if I were to fold it across the vertical line. They are a mirror image. This is the axis of symmetry. Here we have a parabola. A parabola is the name of the shape of a quadratic function. Parabola. The axis of symmetry will cut the parabola into two parts that are mirror images across the axis of symmetry. And the vertex is at the place on the parabola where the graph turns around, meaning it's going down and then it starts going up, or if it was going up and it starts going down. The vertex is bottom or the top of that curve. The axis of symmetry. The axis of symmetry is derived from the quadratic formula. It is x equals negative b over 2a. To solve for the axis of symmetry, first we need to remember the standard form of a quadratic function. F of x equals ax squared plus bx plus c. For our function, f of x is equal to x squared plus 2x minus 1. Our a is the number in front of the x squared term, which for us is an invisible 1. So a is equal to 1. B is equal to the coefficient in front of the x term, or for us, b is 2. We do not use c for the axis of symmetry. The formula for the axis of symmetry is x is equal to negative b over 2a. Substitute in our a and b. We end up with negative 2 over 2 times 1, which is negative 2 over 2, or x is equal to negative 1. We want to graph that on a coordinate plane. The axis of symmetry is a vertical line where x is equal to negative 1. In order to start to find the vertex for our function, we need to take the negative 1 and substitute it in for x in our formula. But we need to remember that f of x is equal to y. They are the same thing. So I get y is equal to negative 1 squared plus 2 times negative 1 minus 1 after I substitute in my value for x. Start to solve this, I get y equals 1 minus 2 plus 1. So y is going to equal negative 2. The axis of symmetry is x equals negative 1 from previous slides. The y value we just obtained was negative 2. To get your vertex, it is xy. You plug in the x from the axis of symmetry and the y value that you just obtained by substituting in your x value into your equation, and you get the vertex of -1, -2. So we have our graph and our axis of symmetry from a previous slide. Then we need to plot our vertex. On the coordinate, it is -1, -2, and we put a dot or plot the point of the vertex and label both vertex and the axis of symmetry. A common misunderstanding occurs by not following the order of operations. Y equals negative quantity 4 squared plus 2 times the quantity -4 minus 1. Common misunderstanding occurs when you multiply the -1 outside of the problem by what's inside the parentheses. And you end up with -4 squared plus 2 times -4 minus 1, which is 16 minus 8 minus 1, which gives you an answer of y is 7. This is very wrong. The order of operations states that exponents come before multiplication. That 2 exponent is only with the 4. It is not with the -1 that is outside of the parentheses. So this problem is wrong. The correct way to do this would be the 4 is substituted in. Do the exponents first. So the -1 or the negative sign is still outside the parentheses. Square the 4 to get 16. Then write the rest of the problem down. Then you end up with -16 minus 8 minus 1, which will give you a y of -25. This is the correct procedure using the order of operations. In this lesson, you have learned how to find the axis of symmetry and vertex of a quadratic function by solving part of the quadratic formula.